Hello, everybody. Welcome back to Chapter 8, Part 2. We're going to look at the production function and law of diminishing returns, and then we're going to look at these short-run cost curves, total costs, total fixed costs, total variable costs, total costs, average costs, and marginal costs. And we'll chart all these costs so we can see that the marginal cost curve intersects the average cost curve, whether that's the average variable cost curve or the average total cost curve at their minimum points. Okay, so let's just move around here. Okay, so one of the key agents in our economy is the so-called firm, the so-called businesses. So what is a firm? It's an organization that brings together the so-called factors of production to produce a product, whether a good or service, that the business aims to sell at a profit. And we assume that profit maximization is the organizing principle behind firms, in the same way that we assume that utility maximization was the primary motivating principle behind consumer consumption and expenditures that we saw in Chapter 7. So utility maximization to consumers is analogous to profit maximization to businesses. And so we assume that businesses act in a way that maximize their profits. Okay. Okay, so we draw this distinction between the so-called short run and the so-called long run. So it's kind of a simple distinction. The short run simply means the time period during which the quantity of at least one input cannot be changed. And usually for businesses, the variable that cannot be changed in the short run is capital. And capital in economics means physical capital, not financial capital. Or at least I should say in this section of economics, in classical economics, capital as an input, capital as a factor of production refers to physical capital. And so when classical economics was developed, it was during the Industrial Revolution, and so there's all this excitement about factories and plants. So we refer to the physical size of factories as the so-called plant size, but I have to admit plant size in a broad economic sense can also apply to productive facilities that are not factories. You know, it could be offices or it could be restaurants. It's still a plant size. Okay, so in the short run, the plant size of a firm cannot be changed. It can be changed in the long run, but not in the short run. Okay, so the long run simply means the time period during which every factor of production can be varied. And this there's no exact length for this. It could be several months, it could be several years, it could be decades. You know, so if you are in a relatively simple business like a restaurant, you can probably change the size of your restaurant in fairly short order. You could rent a larger facility, you could build a larger building, and maybe the long run for a restaurant is several months. But if you're a large factory, it could be several years. You know, I saw something recently about Tesla building a new battery factory down in I believe it's Arizona or Nevada, and it's taking them 2 or 3 years to build this factory. So for Tesla, it's 2 or 3 years. And we know that in Canada, certainly in Alberta, the long run in the oil sands is maybe a decade plus. It takes a long time to get these oil sands projects off the ground. There's a lot of environmental regulations that have to be gone through, and there's such mammoth operations that it can take over a decade to get it into operation. So the long run could extend anywhere from several months to over a decade just depending on the industry. Okay, okay, okay. Oops. Okay, so we have this concept in economics known as a production function. So production is simply the process through which inputs get transformed into outputs. It's inputs, inputs converted into outputs. So it's our factors of production, land, labor, capital, and entrepreneurial skill getting converted into products, goods and services, and the like. Okay, so the relationship between the physical relationship between quantities of inputs and quantities of outputs is known as the production function. And it's a technological relationship because in the long run, technology can change, and this relationship can change. It can change in the long run. So, for example, in the short run, the production function is fixed, but in the long run, it can change. So, if a company adopts more efficient technology, then it can increase its quantity of outputs from a given quantity of inputs over the long run. Or in the long run, companies can increase the size of their physical capacity. They can buy additional buildings, they can build additional buildings, they can buy additional equipment, they can manufacture additional equipment. And in the long run, the productive capacity of the operation can increase. Okay, let's just move on. Okay, so we just said that the production function is the relationship between the physical quantity of inputs and the physical quantity of outputs. And so this so-called average physical product, APP, is the total physical output divided by the total quantity of input. So total quantity of output divided by the total quantity of input. And then we have the marginal physical product, oops, get rid of that, which is equal to the additional unit of physical output for using one additional unit of physical input. So it's marginal physical product is the incremental quantity of output from using one additional unit of input. And when we're speaking of inputs, again, it can be any factor of production, land, labor, capital, or entrepreneurial skill. But as we see in this book, and we see in this chapter, the input that gets used in the examples is labor. And when we're speaking about labor, and as we'll see in this chapter, it refers to labor hours. It's hours, and it breaks it down into an hourly rate. Okay. So we have this concept of diminishing marginal returns. It's kind of a common concept in economics, and I know we've encountered it before. Let's just move on here. Come on. Okay, so the diminishing marginal return. So we're saying that the production function is the relationship between the physical quantity of inputs and the physical quantity of outputs. And the law of diminishing returns says, as we use increasing units of inputs, our physical output first increases at an increasing rate, then the output increases at a decreasing rate, and then finally output actually decreases. Or in other words, it means output increases at a negative rate. So we're gonna see an example of this in the next bit here, or an illustration, I should say. It's an illustration. Okay, so what do we have here? Oops. Okay, so we want to illustrate how the concept of diminishing returns works. So we're going to draw a table of data, and then we're going to plot the data to show that as we increase our output and we use increasing units of input, physical output follows a pattern. It initially increases at an increasing rate, then it increases at a decreasing rate, and then it starts to decline, or we could say it increases at a negative rate. Okay, so this is an example of diminishing marginal returns. Okay, so in our first column here we have input, and we have okay, so they're going to count number of workers per hour, not hours. It's going to be number of workers per hour. So we start with 0 workers per hour, then 1 worker per hour, then 2 workers per hour, and 3 workers per hour. And then we see the total quantity of physical output they're capable of producing. So of course, when we have no workers, we have no output. When we hire the first worker, he's able to produce, or she's able to produce 8 units. When we hire the second worker per hour, then we're able to produce 24 units, third workers up to 39, and so on. And then we calculate the average. So again, we're just using labor as an example of the input. We don't have to use labor. We could use any of the other factors of production, but labor is an easy one to work with because it comes in these discrete units known as workers and work hours. Okay, so the average physical product is simply the total product, total level of output, divided by the number of workers. So, of course, when we have no output and no workers, we have 0 physical product. When we have 1 worker and 8 units of output, our average physical product is 8. So this is column 2 divided by column 1, 2 divided by 1. When we have two workers, we have 24 units of output divided by 2 workers. So we have average physical product is 12 units per worker. When we have 3 workers, we have 39 units of output, 3 workers. Average physical product is 13, and so on. So now we calculate the marginal physical product, which is the incremental increase in physical product divided by the increase in the number of inputs. So this I should go to red here. Orange is maybe better. Well, anyways, red. So here's our marginal physical product. So we have when we hire our first worker, our total output increases to 8 units of output. So this is the marginal is calculated on changes in the total. So when we hire our first worker, our output increases to 8 units, and the number of units of input have increased by 1. So we have 8 divided by 1 equals 8. So that's where this line goes. Okay, and then we hire our second worker, and our level of output increases by 16 units. So that's 24 units by minus 8, that's 16. And how many extra workers did we hire? Well, we hired 1 extra worker, so that's 16 divided by 1 equals 16. Then we hire our third worker. Our total output increases by 15, so 39 minus 24 is 15. How many workers did we hire? Or how many extra workers did we hire? 1. So 15 divided by 1 equals 15, and so on. So when we look at this marginal physical product, we notice a pattern. We notice when our total units of input are low, we go through this stage, oh, it didn't work well. I don't know why it's not working well. Where we have an increase in marginal physical product at an increasing rate. So we went from a marginal physical product of 8 up to 16. And then we go through a period where, as we hire additional workers, our marginal physical product is still positive, but the increase is at a decreasing rate. So 16, 15, 13, 10, 6, and 1. And then finally, we have so many workers are getting in the way of each other that our physical output actually starts to decline. It actually shrunk here by 5. And so our change in our total output is 5 by hiring 1 extra worker. So again, we have minus 5. So our marginal physical product follows this pattern. It first increases at an increasing rate, then followed by an increase at a decreasing rate, and then followed by an increase at a negative rate or simply a decrease. So you'll notice this calculation of the marginal physical product. It's based on changes in the total divided by the changes in the number of inputs. It is not based on, we don't have to have the average physical product figures to calculate this. And again, when we're calculating the marginal physical product, it assumes that all of the other inputs remain fixed. So in this case, the input that we're varying is labor. So that means our plant size stays fixed, our real estate stays fixed, the number of entrepreneurs we have hired stays fixed, and we simply vary this one input. Okay, so now we're going to chart all this data, and we can see. Okay, so we can see. So we're charting our total. We're charting our total physical product versus input quantities. So input quantities per hour, so we have workers per hour. And we notice that there's 3 sections to this curve. We have this section here, so I'm going to call it section A. Oh, sorry. I'm just going to scratch that. Oops, didn't work. Oh, there we go. Okay, so we have section A over here, where we have, as our number of inputs increase, we have output increasing at an increasing rate. Then we have section B here, where as we increase the number of units of input, output increases at a decreasing rate. We can see the slope of the curve starting to curve down. And then we have section C, where as we increase our number of inputs, our output decreases or increases at a negative rate. That's section C here. Okay, and then just to see this a little bit more clearly, we can plot the marginal physical product on the same x-axis, which we do right here, And so here's section A of the total curve, where as we increase the number of inputs, our output increases at an increasing rate. Can't spell. Section B here, as our number of units of input increase, our output, marginal physical product, our output increases at a decreasing rate. And then finally we have the section, that's section B, and then we have section C, where as we increase our number of units of input, output increases at a negative rate, or we can just say it decreases. Our total units of output actually decrease. Okay, so now we're off to look at, so we've illustrated diminishing marginal returns, looking at the relationship between inputs and outputs, and now we're going to look at cost behavior. And cost behavior relates to outputs. Okay, so we have this distinction between one way we can classify costs is dividing them into fixed costs and variable costs. And in some of your other classes, we might use different terminology here. So in math class right now, when we talk about variable costs, I think in math class we just call it costs. And fixed costs in math class, I think we may call it overhead, but it's the same concept. Okay, so we have these two classes of costs. We have variable costs that vary directly with the rate of production. So as we're selling, if we're a restaurant and we're selling pizzas, our cost of cheese is going to, our total expenditures on cheese is going to increase with the more number of pizzas we sell, because we need to have lots of cheese in every pizza. So we have these variable costs. So typical variable costs are direct labor, direct materials. So in a restaurant, pizza crusts and cheese and pepperoni, those are direct materials. And then we have fixed costs, otherwise known as overhead costs. And these are costs that are fixed regardless of the quantity of output, regardless of how many pizzas we sell. We still have to pay rent, we still have to pay property taxes, we still have to pay interest on our loan, we still have to pay advertising, we still have to pay our managers. So these costs do not vary with the quantity of output that we produce. Okay, so what we want to do is we want to crank in a bunch of costs. We want to plot them so we can see the relationship between variable costs and total costs and marginal costs. So we're going to come up with a big data table here, and then we're going to plot it. If I can get there. Okay, so off we go. I can do that. That's something. Okay, so here's our data table. So in column 1 here, we have our quantity of output. So total output per hour, 0, 1, 2, 3, la-di-da-di-da. And then we calculate our costs. So it's kind of backwards here. Oh no, it's not, sorry. So we have total fixed costs. This is total fixed costs. And our total variable costs, and we add them together and we get total costs. So column 4 equals column 2 plus column 3. And then we go and calculate a bunch of all these costs on an average basis. So we simply divide the fixed costs and the variable costs and the total costs by the number of units. So we have column for average fixed costs, we have column 2 divided by column 1. For column 6 here, average variable costs, it's column 3 divided by column 1, and average total cost. The average fixed costs, average variable costs, average total costs, these are all on a per unit of output basis. I should write that down. These are all average equals per unit of output. Okay, and then finally we calculate our marginal costs. And you'll see in this this table here, it's not terribly efficient because column 8 is absolutely identical to column 4. And the reason they added a second version of column 4 was so they didn't have lines drawn all over the slide. But marginal cost is the change, it's the change in total cost divided by change in units of output. So when we calculate marginal cost here, when we have zero output, so when we have zero output, we have fixed costs. We still have rent to pay, we still have property taxes to pay. So even if we have no output, we still have total costs of 10. And then we produce 1 unit of output, and our total costs increase by this variable cost amount, which, anyway, we'll get to that. So increase it by $5 to 15. So our change in marginal cost is, so our marginal cost is a change in total cost, so 15 minus 10 equals 5. And how many additional units of output did we produce? The answer is 1, so 5 divided by 1 equals 5. And then when we produce our second unit of output, our total costs increase to 18. We want to calculate the marginal cost, so it's total cost of 18 minus total cost of 15 divided by the number of additional units of output, which happens to be 1. Again, they made it very simple for us. So then we have 3 divided by 1 equals 3. And then for our third level of output, our total cost equals to 20. So our marginal cost is the change in the total cost divided by the change in the total output. Output increases by 1 unit, so 2 divided by 1 equals 2, and so on. Okay, so now we're going to plot all these costs on some charts here so we can kind of see the relationships between them. So let me clear that, then move on. Okay, oops. So this first chart is simply the chart of the total costs. So we have our total fixed costs, red. So regardless of how many calculators we produce, whether we produce 0 calculators or we produce 11 calculators, our fixed costs are going to stay the same at $10. And we have variable costs that relate to the, so variable costs increase as our level of output increases, and the total cost is simply the sum of, it's simply total variable costs plus total fixed costs. So to get this gray line here, we simply add this green line to the red line, and that gives us the gray line. So you'll notice something in this diagram. The total variable cost line is not linear. So in some of your other courses, in the math course, and I think in the marketing course, when you see this kind of diagram, you'll probably see fixed costs drawn like this, and you'll probably see variable costs drawn like this, and then so we'll have total costs drawn like this. We'll draw them with straight lines. And the reason economists draw the total variable cost line at an increasing rate with a slope that increases, it's because they assume that the supply curve of the inputs is positively sloped. So as we buy more and more inputs, as we buy a greater quantity of our inputs, the cost increases on a per unit basis, and that in turn drives the total variable cost line to increase at an increasing rate. That's not the assumption that we make in the marketing, and that's not the assumption that we make in math class. In marketing and math class, we assume that all units of input cost the same, regardless of how many we purchase. And so the variable cost line is linear, it's straight, as opposed to curvilinear that we see in this economic model. Okay, so we've plotted all three of these costs, and now we're going to recalculate them all on an average cost per unit basis. So to calculate our averages, just to go back here, just to calculate our averages, we're going to simply take our total cost and divide by the number of units of output. So simply a straight division. Okay, so average total cost equals our total cost divided by quantity of output. It's not going to work. Well, it kind of worked there. Okay, oops. Okay, our average variable cost simply equal our total variable costs divided by level of output, and our average fixed costs equal total fixed costs divided by level of output. I guess I should clean this off so you know it's changed. Okay, so the average fixed cost per unit of output is our total fixed cost divided by total quantity of output. Okay, so we can calculate all these average costs, and then we can plot them on a diagram, and that's what we do. Oops, that's what we do. Okay, so what do we have here? Okay, so this is average fixed cost. So remember, when we looked at total fixed costs over here, they simply flatlined across, and this is the level of output. But when we calculate the average fixed cost per unit, our line steadily declines. Why? It's because we have our fixed costs remain the same regardless of output. So as our output increases, the amount per unit of output declines. So if we produce 0 units, that should be shifted. Oh, when we produce 1 unit, okay, I guess I don't calculate for 0. Actually, if you calculate for 0, it goes like that. So if we produce 1 unit, it's costing us $10. Oh no, I guess it goes infinite. Sorry, it goes infinite. We produce total fixed costs are $10, 2 units, average fixed cost per unit are $5. There we go, right there. When we produce 3 units, fixed costs are 10, average fixed cost per unit are $3.33. It's not very good. Anyways, it's about there, and so on. So fixed costs per unit steadily decline as output increases. Okay, oops. Okay, so this is variable costs. Okay, so variable costs. So we saw in our original diagram, or an original chart of variable costs, we had a curve that kind of sloped up like this. And when we calculate average variable cost, which is simply total variable cost divided by total units of output, the curve, the average variable cost line is curve-shaped. It's U-shaped. It's U-shaped. And again, the reason it's U-shaped is because as we need to buy additional units of output, we're assuming that the supply curve for the input that we're purchasing, we're assuming that as we buy additional units, we move up the supply curve for the input, and as we buy more and more units, we have to pay a higher and higher price, and that ends up giving this average variable cost curve a U shape. Okay, and then so this is simply the average total cost curve. So this is simply the total cost curve divided by the divided by the output, number of units of output, and again we see the average total cost curve is also U-shaped. It's also U-shaped. Oops. Okay, so now we're going to plot all these three charts on the same graph, and then we're going to move off to marginal cost curve. Okay, so when we plot all three cost curves, so these are the average costs per unit of output, so average fixed cost steadily declines. Average variable cost has this U shape to it, and the average total cost also has a U shape to it. However, it's kind of worth pointing out that the minimum point of the two cost curves, total and variable, are at different points. The minimum points are at different points. Anyways, we'll come back to that. Okay, we'll come back to that. Okay, so now we want to calculate and plot the marginal cost curve. Oops. Oh my goodness. Oops. Okay, so remember the marginal cost is changes in total cost divided by changes in output. So it basically means how much does our total costs increase for every extra unit of output that we produce. And again, you'll notice that we calculate the marginal based on the total, not the average. We don't even have to know the average figures to calculate the marginal. Okay, so now we want to plot this. Now we want to plot the marginal costs, and we notice that we have this U shape. So again, it's simply the change in the total costs divided by the change in the output. So when we produce 1 unit, our total costs increase from 10 to 15, so that's a difference of 5, divided by change in output, so that's 1, so that equals 5. When we produce a second unit, our total costs go from 15 to 18, so that's a difference of 3. 3 divided by change in additional units of output, which is 1, equals 3, third unit, and so on. So we see that the marginal cost curve, marginal costs first decline, and then they start climbing. And so when we plot that, we also have this U shape to it. Okay, now we're going to plot all four lines. We're going to plot all 4 lines on the same chart. And we want to notice something here. We'll come back to this later, so don't get too excited if you don't kind of get it quite yet. But the marginal cost curve intersects the average total cost curve at the minimum average total cost, and the marginal cost curve intersects the average variable cost curve at the minimum average variable cost. That may not be apparent on this diagram, but these lines are kind of mixed up, but it's the way the math works. And so now we kind of want to look at this to help understand how the marginal cost curve works. Okay, so just before we get there, we have one more diagram to go to first. Oops. Oh my goodness. I think we're back to there. Okay. Okay, so our total costs equals total variable costs plus total fixed costs. And so likewise, when we calculate the average costs, the average total cost per unit equals the average variable cost plus the average fixed cost per unit. So we can simply calculate the average fixed cost amount by subtracting the average variable cost from the average total cost. That's what it's trying to show. So at this point here, average total cost is X, and when we subtract the average variable cost at that point, the difference between the two is the average fixed cost per unit. Okay, so now we want to look at some look at the behavior, the relationship between the marginal cost curve and the average cost curves, both average variable and average total. Okay, so when I look at these diagrams, I just have this little saying. I keep saying that the marginal pulls the average to the side of the marginal. The marginal pulls the average to the side of the marginal. So we can, and this is just, it's kind of a mathematical truism, and so we'll see some examples of it here. Okay, so when the marginal cost per unit is less than the average variable cost per unit, the average variable cost declines. When marginal cost is less than average variable cost declines. That's true. And when the marginal cost per unit is greater than the average variable cost per unit, average variable cost increases. So when the marginal cost curve is above the average variable cost curve, the average variable cost curve increases. And what that means is that it means that the marginal cost curve intersects the average variable cost curve at the minimum point of average variable cost. So when marginal cost equals average variable costs are at a minimum. So you might say, so what? So we'll come back to this later, but what we'll see in a later chapter, that the marginal cost curve above the average variable cost curve is the supply curve. It is the supply curve. This section of the marginal cost curve is the supply curve, a supply curve that we met in earlier chapters. Okay, so now we're going to see the same relationship between the marginal and the average. When we look at total costs rather than simply the variable costs. Oops. Oh, yeah, it's better. Okay, so let's just do that. Okay, so again, the marginal pulls the average to the side of the marginal. So when the marginal cost curve is below the average total cost curve, average total cost curve declines. It declines down to this point. And when the marginal cost curve is greater than the average total cost curve, the average total costs are increasing. And so we see the same thing that happened with the variable cost curve. The marginal cost curve intersects the average total cost curve at the minimum point of the average total cost curve. It's just a mathematical truism. So, but it's a simple way. If you can remember that, it's a simple way to interpret these diagrams. Okay. Oh, but I did want to point out that I did point this out. The minimum point of the average variable cost curve and the average total cost curve are not the same point. They're not the same point. Okay, so that's it for this little section, and then there's one final section to go dealing with the two final subsections of the chapter, but I'm going to do a separate video for that.